Working on the chain. Okay.
Yeah, you got one. Don't forget what's happening Wednesday. Quiz. Like, so let's see, the last. We did the part H, right? Cosecant square?
Yes.
We did that one? Okay.
What's the name of that? Are you looking for?
That's hilarious. I was about to ask you guys.
Hilarious?
No, that's hilarious. I was about to ask you guys.
Oh, okay.
This is not Polaris or something.
Beta?
Beta.
That was such a beta.
Such a big place. Let's
Because
get all that out.
there's a sign in engineering that looks somewhat similar to that, but it's more like a P, and it's used for,
Rho?
it's used for density. Sounded like, why are we calculating density, but no.
Oh, I see. Yeah, I think it, row. Row, right? Yeah.
But then I looked closer and it looks more like a P.
Gotcha. All right, so let's see. You got to knock out the dust that we collected over the weekend. How does chain rule work? Why is this a chain rule problem? Why is this a problem that requires chain rule?
Because it's a function inside of a function.
Yeah. In fact, it's a function inside of a function inside of a function, right? You see that?
Yeah.
And again, whoa, that was good. Again, you don't have to know how many levels there are. This is secant of stuff. Right? How do you take the derivative of secant of stuff? What's the derivative of secant?
What's that?
No? Well, yes, but
Tangent and something else.
yeah, the secant one and the cosecant ones are weird because they kind of like introduce two functions as the answer, right? So the derivative of secant is secant stuff, tangent stuff. And what am I missing? So I did the derivative of secant. It's secant tangent stuff. Are you guys with me?
Your equations.
Yeah, the inside gets a turn now, right?
How you doing? You alright? Okay. I always feel bad for this camera. It's like, why did a math
Teacher buy me. I record all this math. All right, so this is done. This is done. There's nothing I can do here. I really desperately. You really got to be careful about a trig function without something in it makes no sense. This is inside of this, so I can't like put these together. That makes no sense, right? Okay. So this just comes for the ride. And what's the derivative of e to stuff?
Wrong sign. I know the natural log is in there somewhere.
What's the derivative? No. What's the derivative of e to stuff? E to stuff. Times.
Natural log.
Well, natural log of e, which is 1. So e to the x is the only function we know of at the moment whose derivative is itself. Funky dough. And of course, why do I have more stuff here? What's going on?
Because it's still sine b.
Yeah, I haven't taken the derivative of the sine part of it. They each get a turn. So this is like the train moving, and this is me moving on the train. Isn't my total speed, according to somebody standing still, isn't it my speed and the train speed together? So we each, my speed and the train speed should both show up. I don't know if that makes sense. So there's movement within inside of something else moving. And what's the derivative of sine? Jaw. So we got secant, tangent, and then we got cosine, and then we got e to the sine. So however you want to order these things, they're just one big product. I like it. Is that, you guys, what's most important here is, do you understand why I did what I did on each step? And did I have to know ahead of time how many times I would have to do another link? No, I didn't. There's no reason to know that ahead of time. Okay. So you guys try to do number 2 down there. Just to remind you, it's better to write this like this, because that's really what this means. But if you write like this, you kind of lose track of what's where when you're doing derivatives. Let me introduce something. Let me put this on the side here. You see how this is basically this? If I let u equal tangent pi x, right? Okay.
Can you see that? Yeah, you can see that.
You don't have to do this. You don't have to do this. But you see how f prime would be 2u, but isn't u a function of x? So then you have to times it by u prime, the derivative of the inside. I don't know, sometimes that helps people. You don't have to do that. I kind of personally don't like that so much, because then you have one extra thing to keep track of. But it does make the form look better in the middle of the work. So here, the main thing is it's stuff squared, right? That's the outermost function. That's all I have to know at the beginning. It's something squared, some function squared. So how do I do the derivative of something squared?
2 times.
Say again?
2 times.
Yeah, 2 comes down. Stuff to the first power, right? And then what gets a turn then? Tangent. So you pretend like it's something squared. Well, it is. But you pretend like the inside doesn't matter for a moment. Any function squared, the derivative is 2 times thing to the first, but then the inside gets its own term. So this is just coming for the ride. Okay, keep going. Don't tell me, just keep going. Don't tell me, just keep going. Alright, what's the derivative of tangent? Secant squared. I'm gonna slowly try to start getting you guys to realize when the inside function is linear, it's like the constant part just pops out. Because what do I still have to take the derivative of? I'm taking the derivative of tangent? Pi x, and what is the derivative of pi x? Pi. Did I have to know consciously ahead of time when to stop doing chain rule? Right there, is there any more chain rule to do? No, there isn't. So of course I stop, right? But some teachers teach it in this funky way where you have to write all the links out to begin with, and then students don't know where to stop, and that makes no sense at all. You do it as it comes. You don't do it here, you do it next, and then you naturally know where to stop. Hopefully. So I get f prime, let's just clean this up a little. 2 pi tangent pi x, secant squared pi x. Now, how do I finish this off, and what's the equation of the tangent line? What do I need to get the equation of a line? What two things do I need to know? Slope and a point. Y-intercept would be awesome. They didn't give it to me. Oh yeah, it was me. Because I'm the jerk. Right? So I know a point. I got a point. I still need the slope. Yeah, we got the equation for the slope. I know the slope at any point, so I want it at what? 3/4. Plus. Yeah. Now, just in general, if it's an angle you should know, I don't want a decimal answer. You go plugging this shit in the calculator. You should know 3 pi over 4. You should be able to give me an exact answer, not a decimal answer from your calculator. If you can't, come see me. You're supposed to have this stuff memorized. Right? Yeah, why is it negative? Where am I at? Which quadrant is 3/4 pi? Yeah, it's a pi away from a full pi, right? Here's a full pi. Not a pi away, but 1/4 of a pi away. So my reference angle, that's how I show reference angles. Show the angle, and then this is the reference angle. So I know what quadrant I'm in. So I know up here, sine is positive, cosine is negative, because sine likes y, cosine likes x. Yes? So I know tangent's going to be negative, because it's the ratio of those two. And at all the 45 degrees, tangent is 1. So it's negative 1. So this would be 2 pi. Negative 1. What about secant? What is secant? 1 over cosine. And what is cosine of pi over 4? Yeah, back here. So cosine of pi over 4 is? Secant? Yeah, it's root 2 over 2, and it's negative because it's back there. So let's go ahead, put that, and then it's squared. Yes? Oh yeah, and then it's 1 over. Thank you. There you go. Gotcha. Now personally, if I'm doing secant and not cosine, cosine of 3 pi over 4 is negative rad 2 over 2 because it actually is negative 1 over rad 2. That's just been rationalized. You guys said my way? So then secant would actually just be negative rad 2. And why does that make sense? Wouldn't this be 2 over rad 2 when I flip it with the negative? Who cares? What is a whole 2 divided by half a 2? Half a 2. I don't know if you guys are with me at all. You guys are like this too much. Are you guys cool with the fact that cosine is this, which is really this? Which means secant is really this. Which means when I square this, it's just freaking 2, right? Look how gross this looks. This would be 2 over rad 2, right? 2 divided by rad 2 is rad 2. A whole 2 divided by half of 2 is half of 2. Yes.
Like problems like that, are you okay with us leaving the radical on the bottom? Like instead of,
Well, especially because, see, this is fine because I know I'm going to square it.
yeah.
So that's going to take the radical away. Why do we rationalize things to take the radical out of the bottom? So if I'm going to square it, who cares whether there's a radical on the bottom, right? Okay. So eventually, you're going to get 2 over rad 2 is rad 2. Rad 2 squared is 2. So you get negative 4 pi. You need to be able to do the trig evaluation part of this yourself completely fine, right? You have to. And this is just what? This just tells me what? The slope. Is that a slope that you hoped to see? No, too bad. It's the slope you got, right? So I know the slope is negative 4 pi. I know the point is 3/4 1. How do I put together the equation of the line? Probably like that, what you just wrote, Jeff. Right? Now, there's other ways to do it, but like I told you before, I'm going to keep doing this. You could do the solve for b thing, but I'm going to keep doing this because this is going to come back in a slightly different form. And I just really want this in your heads. So y minus what?
1.
The y piece equals negative 4 pi. X minus 3/4. Oh, that's so yummy. Y minus 1, negative 4 pi x plus 3 pi. Yep. So y equals negative 4 pi x plus 3 pi plus 1. Sometimes I get people erase that. They're like, that can't be right. But yeah, that's totally right. Your slope doesn't have to be pretty. What's the y-intercept? No.
3, 5 plus 1.
Yeah, 0, comma 3 pi plus 1. Right. Yeah, this is b. I just can't combine them because pi is free. Okay, okay. How you guys doing? You're like, oh shit. If you're thinking this is a lot for Monday morning, you signed up for it. So I'm going to give it to you. So I really want you guys to notice there's a process. I don't care what the shit these are. There's the process. And it's a brute force thing. Whatever I mean, this could be gross and this could be really gross. You just shove them in. Just shove them in. Solve for y. It could end up looking disgusting. Who cares? It's a brute force process. Yes?
Can you show us that same exact problem, but like solving for b instead of like the...
Oh, yeah, so here's the idea. So I know a value for y when x is 3/4, y is 1, right? And I know the slope, so now I can solve for b. So then I get negative 3 pi, right? Is that cool? Die. Yes? Plus b. So b, add this over. 1 plus 3 pi, which is what we got. Yep. So that's completely valid. And I told you you could do that if you want to. I'm just always going to do this. And again, blah, blah, blah. All right. How you guys feeling? You guys feeling all right? Some of you guys are looking at me like, I don't like you. Oh, well. I'm a math teacher used to it. Let's do a couple more chain rule things to get it really fully back in our brains before we do the next funky ass thing. Let me see. Have we learned? No, we haven't. Oh yeah, that's the next thing we could do. Oh, that's gonna kick ass. Okay. Yeah, good. I like it. Yeah, buddy. All right, sorry. Well, it's gonna be fun. All right. So if I had, let's say, take this guy's derivative. So what do I do first? And I really want you guys to start. The most important thing with chain rule is what is the outermost function? Because it's what gets the whole ball rolling. And it almost doesn't matter at that point what the inside is. It doesn't matter. Whatever the hell I put in here, if I put shit to the 7th power, that's for shit. The 7 would come down times stuff to the 6th power times, and then the inside gets, it doesn't matter even what that shit is, right? I could have said stuff. I could have. But I chose shit. Okay, go ahead. Alright. So what's got to happen first here, of course?
Bring the 7.
Bring the 7 down. You almost don't care what this is. You don't even worry about this right now. 7 comes down in front of stuff. Check. To the
6.
6th power times. Go ahead. I appreciate it. So derivative of the inside. I love it. And sure, you can start doing some derivatives at the same time. But trust me, it's better to get in the habit of writing the rule and then doing the derivative so you don't forget parts of the rule or you don't get stuff in the wrong place. So now this part's done, right? This part's just coming for the ride. And what's the derivative now, tell me? Let me see if you guys are cool with this. And then it would be times the derivative of the inside, which is 5, is it? You see that? What's the inside of tangent? 5x. So the derivative of tangent is secant squared. Derivative of the inside is 5. Let me do that fully out. So you did the derivative of tangent, now you gotta multiply by the derivative of 5x, the inside, right? Minus 2x, that case 5. So, yeah, 5x minus x squared, 6 power. And then I get 5 secant squared 5x minus 2x. There's really not that much. You could bring this out here, you could just do the 7, who cares? It's not really anything substantial, you can simplify. Now, real quick word, if this would have been like a 1/2, and this was 2 secant squared minus 2x, you should kill the 2's. That's what I mean. That's a easy little quick simplification. There's no simplification that makes it any better. So you can stop here. Okay. All right, one more example, and then we'll get into some new stuff. Let's see, what other weird shit? Oh, okay. Before I ask you to kind of get as far as you can with this, what's the very first thing you should do before you do a derivative?
Switch those cube root. We're pretty much like
There we go. Rewrite it as a fractional power. So I don't know if I've told you yet or not. I wish we had never invented radical notation. Radical notation really should not exist. It shouldn't. It's just sort of in the way. Fractional powers are generally easier for most computational stuff we have to do. They just are, including differentiation. So I haven't taken a derivative yet. I'm just going to write this as, right, root on the bottom, power on the top. All right, now go ahead, do it. I just stand here and look at you. Okay. So what's the most important thing to know about this right now, to do the next step? Yeah, it's something to the 2/3. It's all that matters right now. None of this shit matters right now. Right. It will very quickly. How do I take the derivative of something to the 2/3?
Break the 2/3 down.
All blue. We will warn you. So yeah, the 2/3 comes down in front of stuff. No jump. No jump. Why are you trying to make it worse? And then what's this?
-1/3.
Good. Just to remind you real quick, this is true, this works. 2 minus 3 is -1, put it back over 3. I know that seems silly right now, but when you're dealing with fraction like 11 over 17 or something, all right. Times, then the inside gets a turn, and you still don't care about it. You just write it. Now you care about it. Can everybody see this red marker okay? Tell me if you can, it's okay, I'll switch. Some people have trouble with red. Now what happens? What are you doing way up there? What can I do on the inside?
Take the derivative of sine x.
Yeah, so derivative of sine is
2 cosine x. Oh, well, sine is cosine. and
Cosine.
x squared is 2x.
there we go. When you do it all the way up. Right? Derivative of the outside of stuff times the derivative of the inside plus, what's the derivative of e to the 5x? Times
Times 5.
5. Because it'll be derivative of e is e to the stuff times derivative of stuff, which is 5. Yes? No? Okay, let me write it up. So what's the outside function e? The inside function is 5x, right? So derivative of e to stuff is e to stuff, but then the stuff gets a term. That's chain. So I get 2 to the 3rd x squared plus e to the 5x to the -1/3 times 2x cosine x squared plus 5 e to the 5x. And again, there's really no great simplification. You could put this on the bottom. You could even put it inside of a cube root, and who cares? It doesn't really help. So real quick, what's the derivative of e to the ax times prime, right? So it'll be a e to the ax. Do you see that? So when the inside function is linear, all that multiplies by is the slope of that, is the derivative. The derivative is the slope of it. So see how the inside function is linear? The derivative of it will be a. That's the slope of a linear function. See how here the inside function was x squared? It's going to be more complicated. So what's the derivative? So if I have sine ax, what's the derivative of that? Cosine ax times a. So it'll be a cosine ax. Do you start to see what I'm saying? So be careful. This is all still chain rule. The a didn't come out. The a is the answer to the derivative of the inside. So it kind of looks like the a just sort of, it doesn't even come out because it's still there, of course, right? So you got to be careful about little shortcuts like this, but these are remarkably useful, especially when we start doing anti-differentiation. Doing all this stuff backwards, this will be a really cool thing to realize. Okay. So the less comfortable you are, the more you want to show yourself. Do the rule. Don't do the derivative. Do the rule, right? And tell yourself I got to take the derivative of this thing next, and then do it next. Maybe. Okay. Oh. Quick word about notation. In general, if so this means this, right? These two things. A triple equals means defined to be. This is understood to mean this. If I wanted the coefficient of x to be tangent 5, you understand what I'm saying? Coefficient could be 7, it could be 3, it could be 11.2, it could be tangent 5, right? We normally would actually write that here to make it really clear that this is not inside. We could write this, but then I have to write more shit than I should, so we don't. Okay, maybe. Okay. All right. You desperately need to get into section 3.4. You have got to practice this chain rule stuff. You have got to develop questions for me because it is one of the weirder ones.
Chain rules on the quiz on Wednesday, right?
Chain rule is not on the quiz on Wednesday.
Oh, what is it again?
3.1 through 3.3. Product rule and quotient rule and something else, whatever 3.3 was. Trig rules, trig derivatives. Okay, now, let's do some new stuff. Well, first off, I'm going to build to the new stuff. What if I had, what would this derivative be?
7 sine x to the 6 times cosine x.
I like it, right? And then blah, blah, who cares? I don't care right now, I don't care about the next step. What if it was instead, and then blah, 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 blah. What if it was instead, what would you do? 7 times blah to the 6 times blah prime, right? This thing prime. So what's my point? Here's my point. We're about to take a step into okay. If I write this, something like this. All right. Sorry, that's the way things happen. We're trying to get ourselves to a point where we can kind of do this. What is weird as shit about this?
There's y on both sides.
Y on both sides.
Multiple Y's.
This could end up looking like this or something, right? Because the minute I can't, now this one I could probably, I could solve for
You
y.
can easily isolate x. You just divide both sides by y.
All right, there we go. There we go. Can you solve that for y? No. Meaning it's not necessarily a function. It can kind of come back on itself. So let me show you an example. Let me show you what monstrosity, stay with me. What monstrosity, are you for this? Have I turned this on yet? Ever? No. Hopefully this is on.
Yeah, it's turning out.
It is?
Yeah, it's fine.
This is definitely a new projector. There we go. All right, good. Let's see. Okay.
What?
Okay. All right. Can you guys see the equation up there in the corner?
Yeah.
I wish I didn't.
But come on. Just take a step back. I understand you're going to have to work with this kind of shit. Forget about that for the moment. Isn't that flippin' cool?
Yeah, kind of.
Right? I know you're still thinking about, I'm going to have to work with this kind of shit. I'm not going to make you graph most of these things. Right?
Most.
Good catch. We might have to graph a couple of easy ones. Right? In fact, we already know an easy example of this kind of thing. X squared plus y squared equals 1. Is that a function? Is that a function? No, why not?
Because there are multiple y values of 1x value.
Yeah, it fails the vertical line test, right? Portal away. No. Sure. This one is nowhere near as simple, but the main idea is I cannot solve this for y, and you can see that. If I could solve for y, that means for every input, there's one output. That's obviously not happening. In fact, the really freakiest thing about this is this dude, right? Isn't that freaky?
I'd say it's kind of freaky that there's a circle.
There's more. There's little islands. There's probably an island up there. Isn't that crazy?
Did you make Hawaii with Desmos?
Of course.
I can make a drawing on it.
You can make a butterfly.
I do a lot with those ones.
Oh my god, it gets worse. It gets worse.
I
Look at
can't
all
tell
those-
if there's a pattern or
Look at
not.
that.
I think that's the part that messes me
Now,
up.
what's really fun is what if you, I'm kind of zooming out too much. What if I change this to, let's see what happens. Change this to 3.
Oh.
Yeah.
Change this to 2. Right. Change this to 5. That's looking, that's less interesting to me. There we go, I like that. All right. So, here's the main point I want to make. That is weird as shit. But, what is true, at every point on this thing, is there a tangent line? At every point on this graph, is there not a tangent line? Come on, right? If I pick any point, can't you see the slope? Wouldn't you be able to do chapter 2 stuff and estimate the slope there, blah, 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 right? Any point I pick. I can't just say x, because that would be an infinite number of points. So when I give you a point, I have to give you the full point. Before, we didn't have to, because it was y equals there. For every x, there's only one y. So they just had to tell me at x equals 1. If I say at x equals 1, there's an infinite number of freaking things.
Wait, hold on. Can you zoom out? I think I've guessed something, but I want to see if I'm right. Can you zoom out a little?
Can you guys see this real quick? You guys see a pattern here?
So I was wrong.
Isn't this sinusoidal here? You kind of see how it's, if I really zoom out, you can kind of see it a little bit. Isn't it going up and down, up and down, up and down? That's the sign of the cosine.
No, it's like it never goes past -2 or -2.
Yeah, you can figure out why that is too. I love it. I love it. I love it. Anyway, so this is one thing you can play around with Desmos. A lot of people don't even realize Desmos can handle multivariable things. If I change this to y, I'm curious. There we go. That's kind of interesting. Anyway.
I saw a video that someone recreated the intro to Evangelion using Desmos.
Oh. Yeah, you could do.
There's a lot you can do with calculators. Some guy ran the entire game Destiny 2 off a TI-84.
There you go. There you go. Exactly. Of course, you have like people building computers inside of Minecraft and stuff. So I mean, it's it. Now,
Wait, what?
bring you back to this. Look at it. Every point on there has a slope, meaning we should be able to figure out what the derivative of this is. All right, we're not going to start with that function. Don't worry. We're going to build our way up. So this is behind. So this thing we were just looking at here, it should still sort of follow the rules of this. It's just going to be more complicated on the inside. Okay. I didn't. You missed all of that. Here, people at home. There, go to Desmos. Put that in there. Have fun. Okay. You guys are not used to.
You run off a calculator.
Yeah, not many. You're not used to playing with calculators, probably. Too much. Yes? But that, come on, somebody, hopefully, anybody want to go to Desmos and just type in some natural log of x plus sine y, just see what the shit that does? No? No? I love the honesty, so somebody's out there like, I got better shit to do, man. I'm like, all right, I understand. Now, let me back off of this, dude. I definitely don't want to throw this at you yet. Good. So, here, the point I'm trying to make is, I don't have to tell you what this function is. So let me say it's, I don't want to put this. Yeah, I did this earlier. So like, I don't want to say this. Yeah, if it was u, some function of x, wouldn't this be y prime equals 7u to the 6 times u prime, right? Where this would be, somebody would have to tell me what u is. So let me try this. What if I had just y to the 7th? What would that derivative be, knowing that y is a function of x? Y is some function of x. So I had a bunch of shit earlier, different things that had a 7th power, and we basically took the derivative the exact same way. So how would I do this? 7 would come down, stuff to the 6th times y prime. I like it. So, for example, say again? No.
Oh, wait, one.
So let me be even more careful here. Right? dy dx. Okay, now watch. Let me see. So what if I have y equals xy plus 3? Sure, we'll start off with this. We could actually solve this for y, but we're not going to. We're going to take this guy's derivative. Let me be really more formal than I have been. So dy dx equals d by dx xy plus d by dx. So I'm going to take the derivative of each. So d by dx is basically the same thing as prime. It's better though, because again, especially now it needs to come in, because it's telling me what I take the derivative with respect to. So this is dy dx equals, how do I do this? What rule has to happen here? Product rule. So there'll be dx times y, right? Derivative of the first times the second, plus the first times the derivative of the second. And of course, what's this? No. 0. How much is 3 changing? It's always 3, so it's not changing at all. So its derivative is 0. Now look here. What is dx over dx? Freaking 1. But what is dy over dx? I don't know. So that's got to stay. So let me bring this up. So I get 1y plus x dy dx. Now, what am I trying to figure out? I'm trying to figure out what dy dx. I want to know the slope at every point on this graph. I'm trying to figure out what dy dx is. Is that solved for dy dx? Is that solved for dy dx? Hell no. Why not?
Because dy dx.
It's still over there. Don't just say, yeah, it's equal. No, it's still got a dy dx. Of course it's not solved. There's part of it over there. So what do I have to do? How do I solve an equation for a variable that shows up multiple times? I just get everything with that on one side. So I'm going to take this over here. I want to get everything with dy dx in it on one side. Because then what can I do? Factor it out. And then I see there's only one dy dx. There's not 2. There's 1. What's left when I do that?
1 minus x.
Good, 1 minus x. So dy dx equals y over 1 minus x. What's immediately different there from our normal derivatives we've been doing before now? The result is dependent on, so what's the derivative of x squared? 2x. I just have to tell you what x value I want, you can figure out the slope. This derivative is dependent on y and x. So I can't just say find the slope at x equals 1, and I showed you y earlier, because that would have had an infinite number of things before, right? I have to tell you, find, oh shit, Jeff. All right, wait. Find the slope at the point, shit. I've got to solve this thing now, hold on. So if x is 2, y is negative 3. So if x is 2, y is negative 3. Okay, that works. Find equation, tangent line at 2, negative 3. That is a point on this curve, right? If x is 2 and y is negative 3, negative 6 plus 3 is negative 3. So y is negative 3. Yes, maybe. So the points are definitely much harder to get because there's multiple things to keep track of. But how do I do this now? How do I figure out the slope first? How do I figure out the slope of this at that point?
Plug in the x and y values.
Yes, you have to plug in both. So dy, look at this, dx evaluated at 2, negative 3. Oh shit. Just a little bit of a different, there's no like thing I could put it inside of. Does that, so we kind of do it like this. This little line means evaluated at. Later is going to mean evaluated between, but we'll get there. Equals negative 3 over 1 minus 2. Right? Is that cool? Which is 3. Their slope is 3. So what's different here? The fact that you can't solve for y at the beginning means you're going to have dy dx or y prime, however you do it, in multiple places. So you have one extra algebra step at the end. Get all your y prime shit or your dy dx shit together, factor it out, divide. Just a little more work to do. So what's the equation of the tangent line? Y minus negative 3 equals 3, x minus 2. So y equals 3x minus 6 minus 3 minus 9, right? Yes. All right, let's check that out. This is not going to be that funky of a function because, well, let's see if you guys, anybody notices why. So if I plot this, what was it? There it is. That's one, I plot the tangent line. There's the point 2, negative 3, right? Look at that shit. Yes, yes, right? Now why is this graph not terribly funky? That looks like a function, yes? Because again, we could, stay with this thing. Couldn't we solve this for y? Of course we could. Right? So I could have solved for y first and then done all of this. So, let's do some more. Some more examples. So this is what's known as, let's see if you guys can get this word yourself. Before now, in chapter 3, I was giving you explicit functions of x. Meaning, I wouldn't hide what the function did. All right. So if I give you this, that is an explicit function of x. But if I give you this, Do you know what y is? Can you solve for y? Can you get y to be explicitly some function of x? No. So this is implicitly a function of x. This is what's called, when I do differentiation on this, it's implicit differentiation. So that's the title of the section, implicit differentiation, because they didn't explicitly tell me what y was. Nobody here can tell me what y equals in terms of x. You can't. But we can take a derivative of this all day long. Let's see. What do you guys think about this side? I'm going to take a derivative of both sides. Bam. What's happening on this side? What is y? What is y? What is y? I love you guys so much. You're like, what do you want from me? I don't want a number. You can't tell me y is 7. What is y? It's some. It's a variable. It's not independent. Definitely not independent. It's dependent. Yeah. Meaning it's a function of x. It's just a function of x that I can't get. I can't solve for it. Okay. So don't I have a function of x times a function of x? You saw this earlier. That's obviously product rule, yes? So how do I do product rule? Derivative of x is 1 times y plus x times the derivative of y. You do y prime or dy dx. Let's do the prime stuff now. Let's see. I really want you to understand this. So if I said, real quick, on the side. If I said differentiate x times x plus 5 to the 11th power. Differentiate that. What's the main rule you're going to start with? Product rule, yes, right? Isn't this a function times another function? Yes. What if I had x times tangent of 5x? Isn't that a product rule, right? A function of x times another function of x, right? So x times any frickin' function of x. How do I take its derivative? Product rule. Because it's a function of x times a function of x. So all that y is it standing in place of this or anything. I just don't know what it is because they didn't explicitly tell me what it was. But how does it act? Doesn't it act the same way no matter what the shit it is? You know? That's what we saw earlier. I really want you guys to get this. All right. Here. If my function was x tangent 5x, how would I do the derivative? Product rule, good. What would I do? Let's write it all out. I do the derivative of x, tangent 5x, plus x, derivative of tangent 5x, right? And then I would keep going. I don't care about the rest of that. What if it was x times square root of, let's just write it, x times x to the cube minus sine x to the 1/3 power. Yeah. And you want to take its derivative. What would you do? Product rule. X prime times x third minus sine x to the 1/3 plus x times x cubed minus sine x to the 1/3 prime. Right? Blah 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 blah. I could do this all day, right? I could do this all day. So if I write x, y, where y is this, or it's this, or it's anything you can imagine, why does it not matter in terms of what I do? Because they all do the same damn thing, don't they? If I want to take this guy's derivative, it would be x prime y plus xy prime. No matter what y was, we would do that. So this is just capturing that idea. What's really weird is, this is harder, because I got more shit to do. This is easier, because what's y prime? Y prime, I can stop there, right? But it's different. Okay, so coming back to this. xy, derivative, prodigal. Derivative of x is 1 times y plus x times the derivative of y. How do I do this thing? Cosine of stuff. Derivative of cosine is?
Negative sign.
Negative sine. Let me be more specific. Derivative of cosine of stuff is negative sine of stuff. And then what else has to happen?
Derivative of y minus.
Derivative of the inside. Again, you don't have to know ahead of time what's going to happen. You don't have to do it all at once. That's insanity. I just know whatever the shit's inside, I got to take its derivative next. Let me just tell myself to do that and then do it next, right? So now I got y plus xy prime equals negative sine y minus x. And what happens here? What's the derivative of y? Y prime. Good, because I'm doing it with respect to x. What's the derivative of x? Holy shit. That's the end of the calculus in this problem. Now algebra takes over, because what is my goal now? Solve for right? So that's not part of it. This is what I want. I'm trying to figure out what the derivative of the function is, and the function is y. I just don't know explicitly what it is. So what I want to solve for now is y prime. Then I'll know what y prime is. Yes? It'll be a function of x and y, but who gives a shit? I'll just throw a whole point in instead of an x value. So we're still trying to figure out what y prime is. They just didn't really tell us what y was. They sort of like snuck it. They're like, here, we're not going to tell you what y is, but it goes in this thing. And I'm like, oh shit. God, all right, damn it. So then we do all this shit, implicit differentiation. But the minute we do that, now it's algebra. Get y prime by itself. Does anyone see something I should do very first thing? Try to get y prime by itself. No. I don't want to divide by the thing I'm trying to solve for, because then it's on the bottom. That sucks. All right. All right, distribute. Let me go this way. Distribute this sign. Because then your y prime thing is free to move. Don't I want to move everything with y prime to one side? All right. So I get negative y prime sine y minus x plus sine of y minus x. Now what two things do I need to move? What two things are in the wrong place? Good old algebra happening now, right? What do I want to get together? I want to get all the stuff that has what in it on one side.
So you're going to add y prime.
Yeah, everything with a y prime in it on one side, and everything that doesn't have a y prime in it on the other side. Right? Oh, green, are you there for me? You guys see that? No. So I add this over and I subtract this over. All right. So I get x y prime plus y prime sine equals, that's gone now, sine of y minus x plus, I'm getting down, plus minus y. So all I did was swap these. Because now what can I do here?
Factor out.
Factor out of y prime. And then you can divide by all the shit you don't want. Here, write this up here. Now, one level of this that you definitely don't like is everything looks worse, which is only understandable. I mean, you know going in, this is going to be worse because they didn't tell me what y was. And some of you guys are going to get lost in the algebra. It's just unfortunately true. So we end up with, this is kind of a neat, very often you get some really cool, some cool word I can't remember, hold on, some cool symmetry. Watch this, it's got x plus sine of, and this is kind of cool. On the top it's negative y plus sine y minus x, on the bottom it's positive x plus sine y minus, there's sort of a neat, not analogy, but I can't remember the word. So now, if I wanted to know the slope at some point, somebody would just tell me at the point and I could just plug it in. Now, can you imagine trying to figure out a point that actually sits on this thing? Right? I want you to understand, can you see how to figure out a point that's on this graph? Can anybody try to figure out? Can you do it all at once? Can you pick an x and a y and throw it in? No. So pick, like if x were 0, that would be nice, wouldn't it? If x is 0, then I get 0 equals cosine y, and now you can just give me a y that makes that true. Anybody? 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 No, cosine of 0 is 1. Love you guys. Cosine of what is 0? Yes, pi over 2. So x is 0, y is pi over 2. So we got a point that our function goes through. So what's the slope at that point? Right? You just plug it in. So I get sine of pi over 2 minus 0 minus pi over 2. Become a pi over 2. Over 0 plus sine of pi over 2. So you get 1 minus pi over 2 over 1. That's the slope at 0 comma pi over 2. Is it positive or negative? What's pi roughly? 3.14. So half of it is like a little more than 1.5. So 1 minus 1.5 something is negative. Yes, so that slope is negative now. Like it. Anybody want to see what this thing looks like? Actually, I do, so it doesn't matter. Whatever you want. Too damn big. I'm going to do it. Let me see. What was it? What was it? It was, where'd you go? There it is. Is that what it was? Yeah, cosine. Okay, gotcha. XY. Cosine y minus x. Ooh, look at that. Look at that shit right there. And we're at the point 0 pi over 2, right? No. What point are we at? Yeah, 0 pi over 2. So we're at that point right there. So it's definitely a negative slope going through there, yes? So at least that much makes sense. Right? And we can figure out the equation of the tangent line. I really don't want to. Do you guys want to? But there's so many levels to this. And it's not really that far away from what we've done before. And I'm hoping that you guys picked up on that idea. Whatever to the 7th, the derivative basically looks the same. It's got the same form. So it doesn't matter what function you put into that to the 7th power. So I can just represent it with a y and just not tell you. Nah. Right? But then how do you do the derivative of y to 7? 7y to 6 times y prime. Because that's what you would do no matter what the function was I put in there, yes? That is the heart of implicit differentiation. They don't tell you what y is because they don't have to. The rules don't change. And it is definitely one of the funkier things. So let's do one more example and then I'll let you guys out of here so you can go run screaming. Actually, I want to do, let's see. Yeah. Oh, cool. Oh, you're going to love this. You're going to love this a lot. Okay. Let's do 2 things. we know the derivative of this yet? No, we don't. Not officially. You might know it from before, but officially we do not know this. So do you want to do limit definition of derivative to figure this out? Natural log of x plus h minus natural log of e. I don't either. I don't want to do that shit. So let's do this instead. Can anybody tell me how to solve this for x?
Divide by rational
Don't take this wrong, but I want to sit down. Okay. That's the same thing as me saying solve. I'm sorry, Ricardo. Don't take this person. Nothing to do. Other people think the same thing, right? Other people think the same thing. But I got to make a big deal out of this. Nothing against you. That's like somebody saying, there you go. I solved for x. That's done. Next. Come on, teacher. Come on. Come on. This math shit's easy. Yes? Yes? Because this is definitely not ln times x. How do I rewrite log base 2 of 8 is 3? How do I rewrite that?
Ln.
No. Out of logarithmic into exponential.
Oh, you exponentially.
2 to the third equals 8. What's the base here? Base is no, come on.
Ten.
Base of 1, think about it. Would a base of 1 make any sense? That would be what power do you raise 1 to get 7? None. I mean, that would be the most useless function ever. What's understood to be the base of ln? E. Good. X equals e to the y. Those are equivalent. It's arbitrary that we solve for y, to be honest. It's arbitrary that we put the x-axis here and the y-axis there. All that shit's arbitrary. So these are equivalent. Isn't this derivative going to be easy? Even now, notice it's implicit, isn't it? So watch. What's the derivative of x? Let me write this. So let's do the derivative of both sides. Derivative of x. What? Derivative of e to stuff. E to stuff times. No, come on, no.
1?
It's all right. It's all right. It'd be ln e, which is 1. That doesn't show up for e. E is its own derivative. What's the inside? Y. And what's the derivative of y? Y prime. We just did implicit differentiation, right? Derivative of e to stuff is e to stuff times derivative of stuff. We know that. That's changing. I just wrote it as y. I could have written x squared plus 7x. We would have done the exact same thing, right? I really want you to get that. And so what's y prime then? Would it be 1 over e to the y? Yes? 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 No? Just dividing by e to the y. Haven't I solved for y prime? What's wrong with it though? Why is that not satisfactory? This is a function of x, correct? My derivative is a function of y. Wouldn't I rather have it be a function of x? Can anybody tell me, do I have anywhere on the board, do we know what e to the y is? It's freaking x. There, that's the derivative of ln. The derivative of ln of something is 1 over something. Times derivative of y. I love you guys so much. So what we did, we don't know what the shit that is. We can force it into implicit form. This does not tell me what y as a function of x is, does it? It implicitly is in terms of y. I'm sorry, in terms of x. So then I do implicit differentiation, and I know what that is. Bam! Okay, that's one thing. Maybe I won't do the other thing yet, because the other thing is inverse trig functions. And I don't maybe want to slam that in. But let's do some natural log stuff. So what if I add this? What would the derivative be? Let's see. Now we know a new rule. What's the rule for natural log of stuff? It's 1 over stuff times derivative of stuff, right? Because that would be changeable. But the basic idea of natural log is it's 1 over the inside. That's beautiful. That's not that bad. So what's the first step in taking this guy's derivative? No.
1 over stuff.
Again,
1 over
if y is the natural log of x, we now know that y prime is 1 over that. So what's the outside function? What's the outside function? ln, right? Natural log. What's the inside function? X squared minus 2x. So what's the derivative of ln of stuff? 1 over stuff. Times derivative of stuff. Right? Chain rule, yes? Doesn't the inside get a turn? Isn't this just chain rule? So again, chain rule does not give the first shit what the rule I'm looking at to begin with is. It just says, if there's stuff inside of something else, you gotta give it a turn. Chain rule is not a part of any, it's just always in the background, anytime. So we learned a new function, ln x, we know its derivative. If there's shit inside of it, chain rule's gotta come into play. So this first step was derivative of natural log. That's the new thing we just learned. Chain rule says, give that inside stuff a turn. So what do I get then?
2x minus 2.
Bam. Funky del N, right? Funky del. All right, one more, then I'll chat. What if I had, yeah. Is that a product rule? Hell no, it's not tangent x, it's tangent of. So it's immediately a chain rule. What's the outside function? Tangent. So when I take derivative, that's all I care about at first. What's the derivative of tangent of stuff? Secant squared of stuff. Times it gets a turn, right? That's chain rule. Chain rule is mindless. It doesn't care what the functions are. It just says be fair. Outside gets a turn, inside gets a turn. It doesn't care what the functions are. It's not tied to any function. It's just a general rule. So this piece is done. How do I do this? Yeah, good. Derivative of natural log is 1 over the inside times the derivative of 3x, which is 3. Bam, bam. So y prime will be secant squared natural log of 3x. Get over x. All right. And I lied earlier. One more thing. This time I'm telling the truth, and if I'm not telling the truth, you're allowed to slap me. Some of you guys are like, oh man, I hope you try to push it. So then I can officially slap you, but get some aggression out. I understand. Tell me again, what's this? 1 over x. Now watch, this is kind of. One over ax is a good beginning. Derivative of ax, which is a. Do you see how even if there's a constant inside, it's still the same? And why does that make sense? Because what's the log of a product? Can't you rewrite as the sum of the logs? Remember that? What is natural log of a? Physically, what is it? It's a constant. What's its derivative? What's the derivative of a constant? Derivative of a constant? 0. So that's why it doesn't care what a is. And that is enough. Okay. Oh man, I made some of you guys are like, man, what just happened? So obviously next time I'll have some more practice with the implicit. We'll have that quiz first thing. And don't forget we got Friday off, so hopefully does that make you guys back on my side a little bit? You know, we'll find out, man. All right.